Today we will solve together problem 10.1 from the energy chapter, chapter 7. This problem is related to the interactive problem in section 7.10. So that's where we get our information from. So we'll get to that interactive problem and we'll get all the information we need from it. So what we know, we want that the distance is 12 meters. We also know that the mass is 50 kilograms. We know that the velocity is 8 meters per second. And we want to find the force. So, the person is at rest in the beginning. So, initial velocity is 0. And at the end of this distance, we want the velocity to be 8 meters per second in order to do the jump. So I'll write the information I know. So I wrote down all that I know, and I'll try it first. So let's say I decide to put a force of 10 newtons. Oh, looks too little. And the skier will fly and fall. Now if I put 100 newtons, still too little. 1,000 newtons, too much. So I need to rely on the theory I know to solve this problem. I know that the net work done on an object is equal to the change in its kinetic energy. So, I can find the kinetic energy in the beginning. I can find the kinetic energy in the end. So, that takes care of this part. And from the work, I can find the force. Now, in this case, the person has these forces acting on him. There's the force by the ski, by his arms, there's his weight, and the normal force. So the net work would be equal to the work of the normal force, plus the work of the weight, plus the work of the force pushing him forward. Let's take a look at them one by one. The work of the net force is 0. The work of the weight is also 0 because both of these forces are perpendicular to the direction of motion. When you put it that way, you need to explain, and please don't forget the units like I just did. Now, the work of the force pushing him forward is F times D because the force and the direction of motion are in the same direction. So, we have the force of the ski stays as a variable because that's what I'm trying to find. And the distance covered is 12. So it's 12F. I need to leave it as it is. And from that, the work net will be equal to 12F plus 0 plus 0. It is 12. Now let's take a look at the second part of the equation, delta KE. So KE initial is 0 joules because the person is that the final kinetic energy, we can find it from the formula half mv squared, which v? The final v. So half, the mass is 50, and the velocity is 8. Don't forget to square it. Use your calculator to find the answer, and the answer is 1,600 joules. So delta KE is the final kinetic energy minus the initial kinetic energy, which is 1,600 joules. Now I have everything ready to substitute in this equation. That's what I'm going to do now. Work net equals to the change in the kinetic energy. So, work net is 12F equals to 1,600. So the force of the ski is 1,600 over 12, and I use my calculator, and I find the answer to be 133 newtons. I have numbers after the 3, but I use only 3 significant figures because they gave me 3 significant figures in the question. So let's try it. And success.